Greetings. This is Market Sense. Our team members are Nikhil Kumar, Palak Gupta, Pradnesh Fernandez, Shivang Shukla, Shrivats, and Vaibhav Sharma. Welcome to our presentation on Market Sense, an AI-driven stock prediction model that combines the power of technical indicators with real-time sentiment from financial news. Traditional models often rely heavily on historical stock data alone, but markets are emotional, and prices can shift drastically based on news, tweets, or even global events. And that's why we created Market Sense to capture both the logical and emotional aspects of the market. What sets our system apart is threefold: a hybrid machine learning approach that combines both LSTMs and XGBoost for better forecasting accuracy, a real time sentiment analysis using Finbot, a finance tuned NLP model, and Market Sense helps both retail investors and analysts get smarter predictions, not just based on numbers, but also in market psychology. Now let's look at the objectives of our project. The primary goals of Market Sense are to improve prediction accuracy for stock prices by combining both quantitative and qualitative data sources, to incorporate daily sentiment data as a core part of our forecasting pipeline, and to use scalable data engineering tools like RESTful APIs to handle the volume and velocity of financial data, and to create a user-friendly interface using Streamlit, where users can easily visualize model predictions and sentiment trends. Now let's look at the feature engineering inputs. First, we collect historical OHLCV data using Polygon.io's API. And from this data, we generate several technical indicators: SMA, simple moving average for trend direction; RSI, relative strength index to measure the overbought/oversold conditions; MACD, the moving average convergence divergence for momentum detection. And we also include lag features which provide the model with context from past days. Volume spikes are captured using Bollinger Bands and moving average crossovers. And lastly, we inject the sentiment score, a number between -1 and +1, derived from the news headlines for the same day. And all of these features are normalized using standard scaler and min-max scaler so that the neural network can train efficiently. This is the feature engineering workflow where clean stock data and preprocessed headlines are ready. The feature engineering combines relevant attributes like stock indicators, sentiment scores, and time-based features. And these features are merged into a unified database. And this step is shown in the diagram as merge sentiment with stock data. And the enriched data is now ready for the prediction models like XGBoost, and LSTMs. Sentiment analysis. Now, this plays a major role in our project. We believe that the stock market is not only data driven, it's emotionally driven too. And that's why we include sentiment data as a first class input. And here's how it works. Each day we fetch news headlines using Polygon API's news API. And each headline is fed into Finbird, which classifies it as positive, negative, or neutral. And this assigns these sentiments +1 for positive, 0 for neutral, and -1 for negative. And these scores are averaged over the day to give us a single sentiment index for that date. By aligning the score with the trading-based data, we inject an understanding of market tone, which can drastically affect stock performance, especially during earnings, product releases, or global events. Now let's look at Finbot. So Finbot is a sentiment engine, and it's the backbone of our sentiment pipeline. Finbot helps us move beyond simple keyword spotting. It understands financial context. And we use the Hugging Face implementation of Finbot for easy integration. It processes hundreds of articles efficiently and outputs scores that are aligned with each trading day.
So this slide explains a hybrid model architecture containing LSTM and XGBoost for stock price prediction. The LSTM network captures temporal patterns in historical stock data to predict trends or directions. Its output, along with other data, is then passed to an XGBoost model. XGBoost uses this combined input to predict the final adjusted stock price, effectively leveraging both time-based patterns and additional relevant information. Now, this slide illustrates the LSTM-based hybrid architecture. It begins with an input layer comprising technical indicators, lag prices, volume, and sentiment scores. The input is passed through two stacked LSTM layers to capture temporal patterns. The LSTM predicts an initial stock price, which is then fed into an XGBoost model along with other features. This slide presents the XGBoost architecture integrated with a custom Apache Spark pipeline. The dataset first undergoes preprocessing through components like string indexer and vector assembler, converting features into a format suitable for modeling. These processed features are then fed into the XGBoost estimator, which fits the data and generates predictions using an ensemble of decision trees. The output passes through an XGBoost transformer followed by an evolution module. This slide outlines an iterative approach to future price forecasting using a hybrid model that combines LSTM and XGBoost. The process begins with the LSTM model, which utilizes the most recent known data to generate a prediction for the next day's price trend. This output serves as an initial forecast that captures the temporal dependencies in the dataset. Next, the predicted trend is passed into the XGBoost model, where it is combined with additional technical features to refine the prediction and generate the final adjusted price for the following day. Once the final price prediction is obtained, it is rolled into the input dataset, effectively updating and extending the time series. This updated dataset becomes the input for the next round of predictions, allowing the model to learn and adapt iteratively. The app begins by collecting stock prices and financial news headlines. After pre-processing the data and performing sentiment analysis using Birdair or Finbird, sentiment scores are merged with stock data. Features like moving averages and lags are engineered, and inputs are normalized. A hybrid LSTM XGBoost model is trained to predict future stock prices. Results are visualized with charts and sentiment influence is displayed. The client-server interaction begins when a user signs up via the UI. This data is sent to the app client, which performs basic validations before forwarding it to the API server. The server interacts with the user management service to verify and process the data, then stores it in the database. Finally, a confirmation is sent back through the chain to the UI, completing the registration. Now, Nikhil will present the web app.
For the deployment part, we have used Streamlit, which is a Python library or framework which is used for Python-based hosting, web app hosting. So this is the code for our whole model, in which my friends have explained the whole model. And in this code, I have made the Streamlit UI design, and the visualization which will be our output. And at the terminal, I'll run the command to run our web app on the Streamlit platform. So this is our web app. We have hosted in our local system, and it is running on our Safari browser. So yeah, in a web app, we'll start first by writing the name of the stock for which we want the prediction for, and we'll start with the start date. From when we want the historic data of our app till today. So yeah, and when we click on this run hybrid model button, we first, we get the sentiment analysis output. So, like you can see here, we have the date of the news, and then the headline of the news, and the sentiment which our Finbird model gave us, and the feature score of that sentiment. If it's negative, it will -1. If it's positive, it will +1, and neutral for 0. Then we move for the historic stock data and technical indicators. So the first graph indicates the historic performance of our stock for the past 6 months, and the yellow dotted lines show the SMA indicator for our sentiment analysis output. Then next we go for a trading volume over time. So these are for the past 6 months. This is how our stocks has been traded in the volume. Then we go for RSI and MACD trends, which was explained by my friends Pradnesh, and then we go for the historic stock prices, like this is the performance for the stock for the past 6 months. Now our actual output. So from the sentiment and the historic data and the technical indicators, we finally get this output for the next 10 days for the stock. So we can see the future predicted price from today till the next for the next 10 days till 14th April 2025. According to our model, this will be the prices of this particular stock, and this will be the graph of the plotted graph for the price. So, and here we conclude our project for the prediction of a stock using LSTM, XGBoost, and Finbird.